Hello everybody, welcome back to Mastering the Basic Math Facts. We are now in session 7 of the multiplication part of this series. We are looking today at multiplication times 3. So we'll be looking at this in the same way that we have with all of our other sessions, so we won't belabor that point. We'll jump right into our presentation here for today. As we look at our times 3 facts, we might ask the questions, as we have with all the other sessions, why the 3's after all those other facts? And we remember that our 0s, our 1s, our 2s, our 5s, and our 10s, that we're treating those as our foundational facts. Those are the very facts that are going to allow our kids to have the depth of knowledge that they need and the breadth of knowledge they need to address all these other facts. So those first 5 facts we consider our foundations, and now we'll build on those. So without understanding our 2's, it's going to be really difficult for us to strategize to find our 3's. And we know that what we're trying to do here is build a conceptual understanding in our kids and not simply rote memorization. So we know that having that foundation is key to long-term success. We know that by having a lot of previous experiences, we can build on those, and we can use some of those and just add in the 3's facts to those. We're at this point ready to apply the knowledge and skills that we've learned before and ready to jump into the other facts, beginning now with our 3's. So let's jump over, just to remember our sequence, let's jump over to our document camera here. So we've done our 2's, our 10's, our 5's, our 1's, our 0's, and now we begin our 3's. And you'll see today that we're going to treat 3's primarily as the idea of, well, if I can figure out the double and then add one more set of that 3, of that number, then I can figure out my 3's facts. So if I can figure out double 9 is 18, then, well, 3 times 9 must be that 18 and one more set of 9. So I can solve 3 times 9 by understanding what my doubles are, and eventually it becomes a remembered fact, and we can certainly just pull on that as we move forward. So as we go through today, that will be the largest big idea, but we'll look at our big picture and our big ideas here. So last time we looked at our known facts, and again remembering that the grayed out areas are the facts that we figure that kids have already mastered now. The black or the bold facts here are the ones that we're addressing with our times 3's. So you start to see that the unknown facts start to shrink. So we had 36 unknown facts coming into knowing our 3's, and once we know our 3's, we're down to 25 unknown facts at this point. So it becomes a little bit more manageable, again helping our kids realize that it's not all these facts. It's really, we're able to narrow this down quite a bit as we move through. So we mentioned that multiplying by 3 is tripling the number, and this can be thought of as doubling and then adding one more set. So that's one of the big ideas, that probably is the primary big idea with our 3's facts. We know that the other 2 big ideas, these are in all of our sessions, and that is that we have to understand that that our number system is a system. Right, so that kids get to see that all that skip counting, now kids do a lot more skip counting by 2's and 5's and 10's than they do skip counting by 3's, but it's still the same pattern, right? So I can count 3, 6, 9, 12, and that's skipping by 3's, right? They're also going to see that, well, if I know that 3 times 3 is 9, then I can increase that product by 3. So if I know 3 times 3, then I probably can figure out 3 times 4, because it's just going to be 3 more. And we can also find that by repeatedly adding 3. So 3 plus 3 plus 3 plus 3 plus 3 is going to give me 15. I think I did 5 there. So that is, again, understanding that there's a pattern, and that pattern makes math predictable, especially our facts very predictable. And we know, again, that the commutative property is key to understanding and making the number of facts that we have to remember less. So whether I'm visualizing 3 groups of 5 or 5 groups of 3, those are 2 different visuals, but they're going to give me the same value, right, or the same amount. So the questions we might throw out in terms of charts in our room, in terms of just things that we're going to consider throughout our study of 3-ness. We're going to be looking at what does it mean to triple, how is tripling like doubling, how is it different than doubling. What patterns are we seeing? Does the order matter? And then do we notice a connection between multiplication and division? So a lot of these, again, you're going to start to see become the same question just with new facts, right? So that becomes comfortable for kids and adults as well. Our book for our literature link for our times 3 facts is A Three Hat Day. And so you may be familiar with this book. It's a pretty popular book. It was a Reading Rainbow feature. So we should probably have LeVar Burton reading this for us. But we're going to look at A Three Hat Day, and we're going to ask kids to look at the cover in advance of reading this book. And, why might he be wearing so many hats? And let's try to figure out why he's wearing the number of hats that he's wearing. And so let's flip over to our image, and we'll go ahead and read the story together here today. Let me zoom out just a little bit more so that we can see the entire book. So this is A Three Hat Day by Laura Geringer. And we know Arnold Lobel from many of his illustrations and a variety of books that he illustrated over time. So here we go. So R.R. Pottle III loved hats. He loved fur hats and firemen's hats and felt hats with feathers tucked into the bands. He loved top hats and tiny hats. He loved silk hats and straw hats and sailor hats. He loved berets and bonnets and bathing caps and bowlers. R.R. Pottle was the last of a long line of Pottles. Father collected canes. Mother liked umbrellas, and together they took long walks in the rain. After a happy life together, Mother and Father died, and R.R. lived by himself in the Pottle mansion. He was rather lonely. He dreamed of meeting his future wife in the rain, and he dreamed she would be wearing the perfect hat. Every morning when R.R. woke, the first thing he did, before he polished his glasses, before he combed his mustache and his few strands of hair, and even before he yawned, was he chose a hat. Sometimes when he was feeling sad, he chose 2, and he wore them, one on top of the other. One bright, clear morning, R.R. felt so sad, he wore 3 hats. Marching down the street, he passed 2 snakes that were out for a sunny stroll beneath a ginkgo tree. R.R. noticed a cloud hovering just above his head. He passed 2 bluebirds doing a fancy waltz in midair. R.R. trudged on, and the cloud grew bigger and darker. He passed 2 frogs in a pond singing a tender duet. R.R. recognized the tune. It was Estrelita Be Mine, the love song. R.R.'s shoulders drooped. He heard thunder in the distance. There was only one thing left to do on such a glum day. With a sigh of relief, he glided through the revolving doors of the largest hat store in town. What hats! There were fezzes and face veils, tiaras and tam o' shanters. There were sombreros and skull caps, pill boxes and panamas. There were beanies with propellers. There were derbies with green glitter that glowed in the dark, and much more. R.R. began to zigzag in and out among the hats. His spirits rose. He tried on the fez, and he twirled his mustache. He tried on the derby, and struck a devil-may-care pose. He tried on the sombrero, and did a little jig. The pom-poms hit his nose. "What are you doing?" a sharp voice rang out. R.R. was doing a pirouette, and an angry saleswoman pointed at him, scowling. "Stop that!" she said. R.R. blinked and shook his head. He thought he hadn't heard right. It was clear she didn't like him. But why? R.R. took off the sombrero, slipped it back on the shelf, and backed away. Tears came to his eyes, and he turned to leave. Just then a round figure rushed out from behind a curtain. She wore a dress that hung like an apple sack, a lopsided apron, and squeaky shoes. And when she saw R.R., she smiled. It was the sweetest smile he had ever seen. And above that smile was a hat, a perfect hat. And on one side a sequin and a seal balanced. On a sequined seal balanced a shining ball on the tip of its nose, and on the other tiny gold bells jangled. and a plume as soft and gray as fog graced the peak. "Oh, Isabel," the cross one said, "that little man is messing up our hats. Look, he's wearing three, one on top of the other." "Little man," thought R.R., squaring his shoulders, but Isabel was still smiling broadly at him. "Why, Ida," she said, "we don't sell sailor hats." She stepped up to R.R. and gently took off his sailor hat. "And Ida," she said, "we don't sell firemen's hats." And gently she took off his helmet. "And Ida, we don't sell bathing caps either." And gently she took off R.R.'s bathing cap. "It's clear," said Isabel, balancing on her toe, "that this man is no messer-upper of hats." "It's very clear," said she, balancing R.R.'s three hats in her arms, "that this man is a lover of hats." And she beamed. R.R. took off his glasses and polished them with a handkerchief. He cleared his throat. "Shall we go for a walk?" he asked softly. "It is raining, I believe," and he held out his hand. "Yes," said Isabel, taking it. They passed a pond where two frogs sat doing a duet. Isabel recognized the tune. It was, "Love, is that you?" R.R. and Isabel hummed along as they danced down the road. And so Isabel and R.R. Pottle III lived ever after in the Pottle mansion where R.R. the Fourth was born. R.R. Pottle IV did not like hats, she did not like umbrellas, and canes left her cold. R.R. Pottle IV loved shoes. So probably lots of places we could pull in some math here from a three-hat day, but we know we're focused on our times three facts. So let's think about how we can use this text to get us into building a context for our kids in terms of understanding threes and just thinking about threes, remembering that the purpose of the literature link is to be able to go back and say, "Oh, I remember we talked about threes when we talked about a three-hat day, and these were the experiences that I had. So now I, as the student, have something to connect to, and I can pull on that." And so we would certainly want to make sure that our kids were building this context for understanding multiplication by threes, and we'd check, why did he wear so many hats? When did he wear two hats? When did he wear three hats? And hopefully they recognized that early on that three-hat day was just a very, very sad day for him. And a two-hat day was kind of sad, so we might infer then that a one-hat day or no hat day was a happy day, right? So we might build upon that and say, well, how many hats would we need if four people were feeling sad? What if four people were feeling very sad? We want to make it as concrete as we can, so how about we give some kids some Unifix cubes to model the situation? So they're going to have four people, right? If they're feeling sad, well, how many hats would that be? It'd be 4 stacks of 2, right? And then we'd have 4 stacks of 3 for when they were very sad. And what would the multiplication sentences or the equations look like? Well, let's go back to what we know about 4 times 2. Well, that would be 4 groups of 2. 4 times 2 equals 8. And now as we move into threes, well, that's 4 groups of 3. And that would be, well, let's count them all up if we need to do that. We may skip count by threes. We can certainly use whatever strategy we want, but we're going to represent it here as 4 times 3 gives me 12. So again, after reading, we're starting to build the context. This could certainly happen over multiple days. There's no race to get through this. So as kids are then, as they understand the 4 groups of 3 and the 4 groups of 2, let's back up a little bit and let's start building our equations for a 1 hat, a 2 hat, and a 3 hat day. So we would say, well, one man or one woman, whatever, one man wearing 1 hat, well, that's 1 times 1 is 1 hat, right? Well, one man wearing 2 hats is 2, right? One man wearing 3 hats is 3. So we could build that all the way up, and what we would want to do then is build it into or have students work in pairs or trios to show what would this be for 1 hat days, for 2 hat days, and for 3 hat days, all the way through 10 people. So now we're building a lot of multiplication sentences. Remember, the kids have had lots of experience building these sentences as we went through our 2's facts and our 3's facts, or our 1's facts previously, and now we're just adding in the 3's. So some kids are going to want to continue with the cubes, right? And that would be perfectly fine. So I made a chart that might give us the structure. Kids could certainly organize this however it made sense to them, and I hope I've got this right here for us. But my thought was if we looked at the number of people, right, that would be down the left-hand column there, and then is it a 1 hat day, a 2 hat day, or a 3 hat day? So I've got one person, right, times, or 1 hat times 1 person gives me 1 hat. 1 hat times 2 people gives me, oh, sorry, I didn't fix those. I should say 2 hats and 3 hats and 4 hats. So let me go ahead and change that here on our screen just so we have it. I'll fix it in the presentation that we'll post, but so obviously that should be 2 hats and 3 hats and so on down the chart, right? And then as I move over to the 2 hat day, right, so now I've got 2 hats, that's my kind of my constant, right, times 1 person, 2 people, 3 people, 4 people, 5 people, and so on and so forth. And then on a 3 hat day, well, what would that look like? Well, if I'm going to have a 3 hat day, then I've got 3 hats times 1 person, 3 hats and times 2 people. So how many hats would I need for all these variety of situations? It's a lot of math, right, built in there. And we can start then to think about, well, how does what I know about 1 help me predict 2? So how do my 1's facts and my doubles, how does 1 help me understand the other? And then how does knowing my doubles help me find my triples? Because that's really where we want to get kids, right? Is how do my doubles help me predict and anticipate my triples? So we're going to look at how are the times 1, times 2, and times 3 facts alike? How are they different? How do the times 3 facts compare to the 1's? And hopefully somebody would say, well, if I have the 3's my 3 times 2 and my 1 times 2, well, 2, 4, 6, oh, that's 3 of those 2's, right? So that's tripling, and we're starting to build that idea of what tripling looks like. Definitely easier to see as we use the Unifix cubes and having a lot of experiences, and we're going to look at ways to have those experiences. And ultimately, again, we want kids to get to where they understand that the 3's facts, how do they compare to the 2's facts? Well, it's the 2's facts and one more group of that same size. So one way we might do that, right, is having kids pick a number of people. So the example we're going to choose is 6, right? So, all right, if we have 6 people, show me the stack of cubes that you would need to use to represent the total number of hats on a 1 hat day. So we'd have 6 sets of 1 cube, right? So I'd need 6 hats, right? Well, now if I have a 2 hat day, well, now each of those same 6 people, they're going to get 2. And now I've gone from 6 times 1 is 6 to 6 times 2 is 12. And then how would that compare to the 3 hat day? Laying those side by side would certainly give the visual and the quantity view, the magnitude view for kids as well. So let's give another chance to explore the facts. So we had the literature, we've done that for a day, 2 days, 3 days, whatever it's taken in terms of reading the book and doing the activities. Now let's take it and change the scenario just a little bit, but we're still going to focus on the same thing, doubling and tripling. So we're going to use this scenario that the text shares with us about the Franklin Zoo, right? And so they have twin apes, and they have names here, and then they have triplets that are chimpanzees, and they've got all this food, right? So they've got the zookeeper wants to feed all these different animals, but the key being that they're going to use just these types of fruits, and they have this number of things. So how many of each fruit would the zookeeper need in order to create fruit baskets for the twin apes? Well, what are we doing when we make the kids work with the twin apes? Well, they're each going to need 2 of those things, right? So now we're talking about doubles. And so we have a sheet here to kind of organize kids' thoughts. And again, all these are in the digital downloads from the text, so you can pull those down if you choose to get this resource. So as we look at this, so if we're doubling and tripling baskets of fruit, right, we're going to have to double if there's 2 apes. So if I get a grapefruit, right, that means I need 1 grapefruit in the basket, right? So if I'm giving it for the apes, I'm going to need to take that times 2 because they're going to want 2 grapefruits. They're going to want double the number of peaches, right? So they're going to need 4. So The concept being that whatever the pieces of fruit is, that's the pieces of fruit in each basket, right? So they're going to organize their work, and in essence, they're creating their multiplication chart here again for times 2, and then they're going to need to do that for times 3 as well. And of course, we'd want to have counters available, so as kids start to fill in the ape twins, they would be able to have the counters if they need them, and if they want to jump right to the chimpanzees and figure out how much they're going to need for them, then they could certainly do that as well. So once we have the whole chart filled in and we've discussed how we got there, we'd want to start now looking for the patterns, right? So hopefully we could ideally go back and review the 2's patterns. Well, what was skip counting like there? What do we remember about 2's? Well, they're always even, right? And they count in that 2, 4, 6, 8 pattern, right? And it's going to repeat over and over again. So as we add in the 3's column, now we're going to look for those same kind of patterns. Well, they're not always even, right? Do they rotate even, odd? We want kids to start recognizing those pieces. How can they use what they know about skip counting to find their 3's? And we start to plant the idea, if no one has brought it out, right, that is tripling like doubling? And if it is like doubling, then how so? And some kids are going to see that right away. Other kids are not. Some kids are going to see it once somebody points it out. Some kids aren't going to see it for a while. But we want to start planting that idea if they don't just intuitively see it. And for especially early on, a nice challenge is if I gave you a number and said, this is double the original amount, could you find the triple? So if I said that double something is 10, well, what's the triple? And you can really start to see that this is algebraic thinking, right? If 2 times a number is this, what is 3 times that same number? So we start to see if 2x is 10, then what is 3x and what is x? So those really, we can see that beginning level of algebraic thinking, it can be missed if we aren't building a conceptual understanding of our multiplication facts, because you won't notice those things if we just do rote memorization, right? So this is a real good chance to start getting more in depth with the mathematics, even with just simple facts. So how do we continue to support our kids, both those who struggle as well as those who are doing okay, but they might just need some more practice? So here's going to be a couple activities that can be done small group, whole group, whatever works. They can certainly be done as stations as well. So this one's called visualizing doubles and triples. So we're going to take something like 2, and we're going to give kids counters. So let's put 2 counters in times 1. So our times 1 is going to have 2 in it, right? And then let's double that. So if I double my initials, that's kind of my x, right? That's my beginning point. If I double that, what do I get? Well, that's 4. And then if I go back to my original times 1, my 2, so I have 2 counters there, and I say I want 3 sets of those 2. What is that? Oh, well, 3 sets of 2 is 6. Oh, now I had that experience going through that. I might have to do this a bunch of times. It's going to, some kids are just going to want to go 2, 4, 6. So we said, no, let's go back and let's remember where we start. We're going to start with that 2, and we're going to double the 2, and then we're going to triple the 2. So we want to keep coming back to that. And and as we build on that idea, then we're going to start saying, well, if I know the double, how can I find the triple? Right? How does that? If the double is 8, well, what's the triple? Well, if the double is 8, then that means the original must have been 4. So that means the triple must be 12. So we're going to do that, and we're going to build all the way up through all of our times 3 facts, and we do that by starting with 1 counter and then 2 counters and 3 counters all the way up to 10 counters, and be able to lay them right on the work mat. Another suggestion is looking for the patterns on a hundreds chart. We're going to actually make this 100 chart start with 0. So this is a 0 to 99 chart. It's still 100 spaces, right? But it's going to start with 0 because there's certain patterns we're going to see in a chart that's structured this way that is different than if we start with 1. Right, and so we definitely want to start with 3 for this chart. As we look here, we're going to start to see, well, where would my 3's fall? And so we would have kids mark their multiples of 3. So we're going to put, well, 3 times 0 is right here, and then 3 times 1, and then 3 times 2. And some kids are going to be thinking of it as 3 times, and some kids are going to be counting up by 3, right? And then we have 12 and 15, right? So we're going to stop at some point and say, well, what do we notice as a pattern? And some kids are going to start to say, well, it's kind of a diagonal going this way. Well, let's see if that works. Is it predictable then that where would the diagonal go here? Well, it would be 21, right? And then 24 and 27, and this would be 9 times 3 or 3 times 9, and then 10. Oops, I put that in the wrong place. And then 3 times 10 would be over here. We could also do things with this once kids had some experiences with the chart. We could do some proposals, right? We could say, well, what about 53? Do you think that's a multiple? And some child's going to say, well, it doesn't fall on that diagonal, so it probably isn't. And then we could find different ways to see what is a multiple of 3 and what's not. Again, just going back through these, lots of repeat practice. We need lots of different ways to get kids into it. So this being a separate or another way to do that for us. We'll pull back out of our chart here. So there we go. Another activity, and again, not to make it sound like these are all happening at once. These could certainly be stations. They could be ones that progress one from the next to the next. Some kids might do all these. Some might just do a few. I would caution, we don't want kids doing none of them. They need the concept piece, right? So we're going to look at connecting cubes. This is going to go back to what we did early on with the 3-hat day. So we're giving kids a basket of cubes, and we're asking them to make 10 chains of 3. So they're making these little stacks of 3 like you see on the worksheet there. So we're going to pose some math facts. Okay, 5 times 3. Can you show me that? Well, that would be 5 of those little stacks, right? Okay, well, let's draw that out. Then we have for the actual activity, so once they understand the point of this or how they're going to do it, we have a spinner for them here. And so they're going to spin the spinner, they're going to multiply it by 3, and when they multiply it by 3, so let's say I get 8, well then what am I going to draw on my paper? I'm going to put 8 stacks of 3 on my first one. And 8 stacks of 3, well, how many is that? Well, I'm going to write my multiplication sentence. 8 times 3 is, and if I'm not sure, I've got the cubes right there to solve it. And I'm going to do that 3 times. You could do this a lot. You could do this repeatedly. You could do it as a challenge in terms of how many, who gets the most wins if you wanted to make it into something of a little activity or game activity. Another way to get into 3s is to think about what comes in 3s. There are lots of fairy tales, right, that deal with the number 3. So 3 bears, 3 little pigs, all those things. And talk about, well, what if I had 3 sets of the 3 little pigs? How many little pigs would I have? If I had 3 tricycles, how many wheels would I have? If I had 5 triangles, 7 triangles. So again, just helping kids realize that 3s come in a lot of different scenarios, and we can pull them out of a lot of different places. An additional way to get kids to think about the multiplication facts is to write about them and to discuss them, of course. And we see that in each of the activities when we have them write things down. But one of the suggestions from the text is to do like a 3-column chart. This could just be a folded piece of paper, no magic to the digital download here. So they're going to select a multiplied by 3 fact. So I'm going to pick 4 times 3, right? And say, all right, so now write a word problem that goes with that 4 times 3. In the second section, I want you to draw the array or a picture that shows 4 times 3. And in the third column, let's share, how do you solve 4 times 3? How do you remember 4 times 3? Do you remember it's double 3 twice? Do you remember it's 3 times 3 and 3 more? How do you think about that multiplication fact? And these can be great for kids to share back and forth. Automaticity, we know that this comes after kids have lots of activities. This can't be the first time or even in the first day or two really that we're working with this fact. We want lots of experience with the fact before we start getting to this sheet. Otherwise, those are just numbers on a piece of paper, right? So we have our multiplication and division fact cards that we have for kids. We're going to talk about triangle fact cards in a second, but this is one way that we can practice do some targeted practice. We have our mixed review practice. We have just multiplication by 3 facts, and then again the mixed review in terms of a short sheet. I'm sorry, I called this one the mixed review. This is actually the kind of the assessment piece here. So we're looking at how many of our multiplication facts do we get, how many of our division facts do we get. We mentioned earlier about monitoring student progress through individual checkups, and so we shared this in an earlier session, so I won't go into that too much in depth. But remember, you're going to pick 10 facts, interview the child, work through, was it automatic for them? Did they use a strategy or was it unknown? And so we're targeting certain ones. This is based upon which facts they were struggling with before. Another way to build automaticity, another game to build automaticity, right? This one is a strategy game, and this one's going to be a little tricky for some kids. So again, they're going to use a spinner, and they're going to multiply by 3. And so they spin it, they get 5 times 3, and they're going to have to decide. And so the strategy certainly comes in as kids have to decide, well, where would I put that, whatever, if I did 5 times 3, where would I put that 15? Oops, sorry. There we go, now we're back. Where would I put that 5 times 3 on my number line? Because in the end, my numbers have to be in order. So if I put the 15 at the very beginning, then all my other answers are going to have to come after the 15. If I put the 15 at the end, then all my other answers are going to have to be less than that. So I can get myself stuck if I put two numbers too close together. And again, the first person who can fill in their number line is the winner of the game. So again, a little bit of strategy to make it a little more, maybe just a little more intriguing for the kids. Another way, and we mentioned this a little bit ago, is the triangle fact cards. And so in the triangle fact cards, these are the product and the 2 factors. And you can see that the product is circled on each card. So if you cut these apart, you can pull one out, and the idea is that you cover up one of the pieces on the triangle. So if I want to do multiplication, obviously I'm going to cover up the product. I'm going to say, well, 0 and 3, if I multiply those 2 together, whatever order I want to think of them, what's my product? Later, we'll look at these with division, because obviously that plays in here too. These are great for 2 kids to work back together. It's another version of just using our traditional cards, but it does lend to the idea that there are 3 numbers, and 2 of those factors come together to produce a product. So just another way to get kids more experience. And so here's the other one of the 3's facts. Again, these are all easily editable on your digital download. So as kids go through these, kids are going to write the multiplication. They can write the multiplication sentences. They can write the division equations. And so again, just trying to build automaticity by giving a number of repeated experiences. One of the activities we mentioned in the last session was using the blank multiplication chart. If students kept their multiplication chart from the last time, and remember they were filling in the facts that they own, the ones that they know. So I could be filling in the 3's facts now. And I started to see for my own personal self, where am I in terms of knowing all my multiplication facts? And I think in part for kids, this helps them realize that, oh, there's not that many left. And it also helps them realize the ones that they know and the ones that they're still struggling with. So using colors to indicate those is always a good idea. So as we get close to the end here, we always like to come back and say, well, how does this connect to division? We know that pairing multiplication and division helps kids understand that they're not 2 totally distinct things. They're not a different set of facts I have to remember. So we could use that original context from the baskets of fruit, right? And remember the situation with the zookeeper. So now, instead of giving them what goes in each basket, now let's say this is what he bought. So he bought 3 grapefruits, 6 peaches, 9 oranges, 12 apples, 15 lemons, 18 bananas, 21 strawberries, 24 raspberries, 27 grapes, 30 blueberries. That's a lot of information. So for some kids, you might narrow that down. For other kids, we're only going to ask them to look at 3 of these at a time anyway. But that might be a little overwhelming for some kids. So the question is, how will the zookeeper figure out how many of each type of fruit should go in the basket? So we have to remember that each chimpanzee gets the same amount of each type of fruit. And there are 3 chimpanzees, right? So if I choose grapefruit, well, how many grapefruit is each chimpanzee going to get? Well, that's 3 grapefruit divided into 3 groups. well, each one's going to get 1, right? If I pick apples, well, 12 apples broke into 3 groups, 3 chimpanzees. How many does each get? Well, I might have to draw it out at first. So what I might think of it as what times 3 gives me 12. So there's a cognitive leap there, I think, for kids. But using a similar context is one way to help kids get there. Using counters is Unifix cubes are nice because you can kind of color coordinate with the objects to help kids. We talked about using our triangle fact cards as well. So now instead of covering up the product, I would be covering up one of the factors, right? So I would say, well, the circled number is our product. So if I use the 632 triangle there on the top row, right, I would be saying, okay, so I'm going to cover up the 2, right? And I'm going to say, well, the product is 6, or the answer is 6, so 6 divided by 3, what's that going to give me? Well, what times 3 gives me 6? I could think of it that way. I could think of it as 6 spread across 3 groups. What does that give me for each group? And again, just the remainder of the cards there. So just as we've done with each of the PDs, we have kind of a closing to do. We want this to be meaningful for you. We know it's hard in a semester or in a couple weeks, not even a semester, to think about, well, how would I jump into applying this? Well, you don't necessarily have to. We would like you to think about how you would use it in the future, and especially if there are tools or resources that you are using, especially for your 3s facts right now. If you'll attach them to the post, that will be very helpful. Up next, we're going to go to times 4s and then times 6s. Once we go through this group of 3 facts, 3s, 4s, and 6s, then we'll give you an assignment for those 3. So your simply right now is just to watch this, and we hope, again, this is added to your toolbox. And we look forward to seeing you in our next session when we'll be looking at multiplying by 4.